Alright, so today we are going to learn how to evaluate something called a factorial and something called a permutation. And a permutation is all the possible arrangements of a collection of things when the order is important. And then tomorrow we'll talk about combinations, and that's when the order is not important. Okay? And we'll talk about the differences between those. But today, order will be important for most of the problems. So, first one, Robbie is about to eat his top 5 candy bars. And his top 5 are Reese's, Snickers, Three Musketeers, Twix, and Butterfingers. How many different orders can he eat all 5 of the candy bars? How would you find that out? So yesterday, we would take 5 times 5 times 5 times 5 times to get the number, correct? But something's different today, because once you eat your Reese's, it's gone. You can't eat it again. Once you eat your Snickers, it's gone. And so, thinking of the combinations, I wouldn't copy this part down, but you could do a Reese's, a Snickers, a Three Musketeers, a Twix, and then a Butterfinger, right? You could do a Reese's, a Snickers, a Three Musketeers, a Butterfinger, or a Twix. Now, order does matter, because otherwise there'd just be one combination, because you would just eat them all. Okay, but they're asking, in how many different orders can you eat them all? So we could keep listing them: Reese's, Snickers, Three Musketeers. I guess I would have something, huh? Butterfinger, Three Musketeers, then a Twix. Anyway, anyone have any idea how many combinations of eating these candy bars there are? Let's think about it. You're going to eat a candy bar. Then you're going to eat a candy bar number 2, right? And then you're going to eat a bar number 3, bar number 4, and bar number 5. So you're going to eat something, you're going to eat something again, eat, till all your candy's gone. So you're sitting there trying to decide. Right now, before you start eating, how many candy bars from? Yeah, you could choose any of the 5 you want. And then what happens? You still have 5 candy bars? Or do you now have only 4? You only have 4, you ate one, right? So now, candy bar number 2, you have 4 options. Now you've eaten 2 candy bars. How many candy bars would be left? 3. So now you have a choice of one of those 3. You eat a 3rd candy bar, leaving you 2 candy bars. And then at the very end, you'll have 1 left. Okay? So we learned yesterday that you just multiply those together. That's exactly the same thing. Now you may see this written in math as this: 5 exclamation point. And all 5 exclamation point, that means 5 factorial. That's what this word means, factorial. It looks like this. Looks like an exclamation point. And all that means is a simpler way of saying take 5 times 4 times 3 times 2 times 1. And if you do 5 times 4 times 3 times 2 times 1, you get 120. So I would say there are 120 orders to eat all 5 candy bars. You guys believe me? If you don't, start listing them out and you'll see that there are a lot of combinations. Also, your calculator. Can do this. So you just go 5, and then it's under, I always forget, math, I believe. I believe it's under number. No, it's under probability. That makes more sense. There you go. And it spits out 120. 5 times 4 times 3 times 2 times 1. So if you get something silly like 18 factorial, and you don't feel like typing in your calculator 18 times 16 times 15 times 14 times 13 times 12, because each time you're eating a candy bar, right? You know, 18 candy bars, how many different orders are there? Eat 18, eat 17, eat 16, eat 15, eat 14. You could just use the shortcut method, okay? Which is 6.4 times 10 to the 15th. There are a lot of combinations. Assuming all those candy bars are different, okay? Now assume, same problem, that Robbie, we know, ate the candy bar, ate the Butterfinger first. And the Twix third. How many combinations are there now? More or less? Less. In other words, right here, we know he ate the Butterfinger. And right here, we know he ate the Twix. Correct? So instead of 5 options, there's only 1 option. It's a Butterfinger. And instead of 3 options, there's only 1 option. We know it's a Twix. Okay? So we have candy bar number 1, which we know is a Butterfinger. And then we could call this still bar number 2. We could call this, this would be his Twix, right? We'll call this bar number 4 still. We'll call that bar number 5. The only difference in this problem is we know there's only 1 combination there, a Butterfinger, because they told us it's a Butterfinger. And there's only 1 combination here, it's a Twix, because they told us it's a Twix. So let's think of this. You eat a Butterfinger, right? And you know that you ate the Twix third. So if you ate the Butterfinger first and the Twix third, how many other candy bars are possible to go there? Yeah, there's only 3 candy bars that could go there. The Butterfinger and the Twix, the other candy bars. So there's only 3 combinations to go there. Those 3 could be, it could be a Reese's, it could be a Snickers, it could be a 3 Musketeers, but it cannot be a Twix, it cannot be a Butterfinger, because we know where those were eaten. So you eat a candy bar, right? And we know that this was only 1 combination. What would this be? You eat a candy bar, you eat a candy bar, you eat a candy bar, leaving 2 candy bars that could go there, and then 1 that could go there. Type that in. 1 times 3 times 1 times 2 times 1. There are 6 different orders. Let's try listing out all 6 different orders. So we know the Butterfinger came first, right? And we know the Twix came third. And there were 5 of them. And there were 6 of them, right? 1, 2, 3, 4, 5. Let's go through. There might be more. Maybe we messed up on the formula. But Butterfinger, Twix, what's one order that could go here using those 3? Reese's, Snickers, Three Musketeers. That's one. Okay. What about the next one? Couldn't I make this Reese's and just switch the Three Musketeers with the Snickers? Any others? A Snickers, a Reese's, a Three Musketeers, or a Snickers, Three Reese's. Ooh, that sounds good. And then what else could there be? They could also eat the Three Musketeers first, right? And then the Reese's, then the Snickers. Or maybe the Three Musketeers, Snickers, and Reese's. Well, that is all the combinations there are. There are no other combinations. Either you eat the Reese's second, the Snickers second, or the Three Musketeers second. There were 3 options, right? And then once you choose one here, now there's only 2 candy bars to pick from here. Go here, and then you just write what's left in the last column. Well, those are all the combinations. I should say permutations, because order matters. Alright, so there's something called factorial notation that helps. 4 factorial means is 4 times 3 times 2 times 1, which is 24. And 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1, which again, you can either just type it in, 7 times 6 times 5 times 4 times 3 times 2 times 1, or you could do 7, math, PRB, factorial, and it'll spit out 5040. So factorial is just a way of saying, take 7 times every number minus 1, minus 1, minus 1, until you get to 1. So that's saying if we had 7 different candy bars, when we were to do the same problem, we would have 5,040 different orders. Okay? Now a little bit of math. 8 factorial. That means 8 times 7, 6 times 5 times 4 times 3 times 2 times 1. Correct? And 5 factorial means 5 times 4 times 3 times 2 times 1. Lucky for us, 5 divided by 5 is 1, 4 divided by 4 is 1, 3 divided by 3 is 1, 2 divided by 2 is 1, 1 divided by 1 is 1. Anything times or divided by 1 is the same thing. So this is really just asking, what is 8 times 7 times 6? and it's 336. Or type in 8 factorial divided by 5 factorial. Same answer, see? Let's think about this one. If you have 25 times 24 times 23 times 22 times 21 times 20 times 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And this one, it's 23 times 22 times 21 times 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So what's going to be left? Well, we'll start with 25 times 24 times 23. Will 23 be in it? No, because everything after 23 is going to cancel out, right? Everything is going to cancel from then on out. So this is really just a fancy way of saying what's 25 times 4? 600. What about the next one? 500 times 499 times 498. Now, I'm not counting all the way down from 500. And then the next one, 499 times 498 times 490. What would be left? Yeah, just 500. Now, why teach you how to work with these when you can just type it in your calculator? Because your calculator isn't that smart. It's going to do 500 times 499 times 498 first, and then it's going to do 499 times 498 second, and then it's going to divide, and look what happens. Overflow. In other words, this number is way too big. You can't do it. That's why you have to a little bit about factorials to know that this is really just 500. Okay? Questions so far? Now, permutations. And we have this formula. Maybe you didn't want to eat all the candy bars. Maybe you were just going to pick 2 of them. Maybe you weren't going to do 5, pick 5. How many combinations were there when we had 5 candy bars and we were eating all 5? Do you remember? 120. Now, the order you ate those candy bars did matter. Look, 5 P5, that means you have 5 candy bars and you're eating all 5 of them. What if you only ate 4 of them, you left 1 on the table? Would there be fewer or more? There would still be 120 combinations. Why? Because that last candy bar you ate was going to sit on the table no matter what, right? It was going to be your last choice either way. So whether you picked 4 or 5, you're going to get the same thing. What if you picked 3? Fewer or more? Fewer, right? Now there's only 60 options. What if you only picked 2 candy bars? There's only 20 options. So it'd be like Snickers Reese's, Snickers Twix, Snickers Three Musketeers. I don't remember all the candy bars. But there'd only be 20. What if you have 5 and you pick 1? That one should be easy. You have 5 candy bars, and all you do is pick 1 of them. How many combinations are there? How many candy bars were there? 5, right? So you either pick up a Reese's first, or you pick up a Snickers first, or a Three Musketeers, or candy bar number 4, or candy bar number 5. There's only 5 options, right? And then deciding not to name them, that's one choice, right? Does that make sense what this is for? The formula is right here. So it still has the factorial, but at the end you divide out the ones that you're not going to eat. Okay? So John is the coach of a 13-player baseball team. Although there are 13 players, the batting order only consists of 9 players. How many different batting orders can John create? So not everyone always gets to play a sport, right? Now the way this formula works, your total goes here, how many you pick goes here, and then you just plug in the formula, okay? So, how many players are on this team? There's a total of 13 players to pick from. Players. And P, how many is he picking? 9. There's 2 ways to think of this problem. One is, well, he's going to pick 13 players, and then 12 players, and then 11 players, and then 10, and then 9, then 8, then 7, then 6, then 5, then 4, and then 3 players not chosen, right? So the formula says you take this number, put it on top, and then you divide it by this number minus 9 is 4. You see how I got that? Because there's going to be, I said 3 players not chosen. Basically, you're dividing out the 4 combinations of players that aren't going to be chosen. That's what you're doing. So, all this is saying is, for the first batting order, you have 13 people to pick from. For the second batting order, then 11, then 10, then 9, then 8, then 7, then 6, then 5. So I got player 1, player 2, player 3, player 4, player 5, player 6, player 7, player 8, player 9. And we're going to stop because that's all the players we need. Does that make sense? Or 13 factorial divided by 4 factorial would just be the same thing, right? 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5. Cross off the 4, cross off the 3, cross off the 2, cross off the 1. So that would be 259,159,200 permutations. Or I'll say different batting orders. Your calculator could also do, you go 13, and then you go back to your math button, go to PRB, see the NPR. So NPR is when order matters. NCR, that would be when order doesn't matter. You just need people on your team. It doesn't matter what order they bat in, okay? But we would choose NPR, and we would put in 9. See, it spits out your 259 million. But it's good to understand the formula too. because I always forget the formula. Next, suppose that 20 people are running in a race. The first 3 places are awarded gold, silver, and bronze. So does order matter when you finish? It does. So it's a permutation. Now,